In the Karnataka SSLC science exam, a massive 12 to 16 marks are tied directly to these diagram-based questions. Examiners do not grade these based on artistic talent. They look for specific visual cues, accurate proportions, and overall neatness. To achieve that neatness, you have to follow strict physical rules. Pens are completely banned for these drawings. You need just 3 tools: a sharp graphite pencil, a standard straight ruler, and a clean eraser. Mastering these drawings is a highly efficient way to prove your scientific knowledge. It allows you to secure maximum points quickly, without risking errors in lengthy written paragraphs. The most important structural rule is orientation. All text labels must be placed on the right-hand side of the drawing. Next is the ruler rule. Use a straight edge to connect the anatomical part to its label, eliminating any wavy, unprofessional lines. Below your drawing, you must write the specific title of the diagram and clearly underline it. Adhering to these rigid formatting standards removes cognitive friction for the examiner. A mediocre sketch instantly elevates into a full-mark submission when it is perfectly organized. Let's apply these rules to biology, starting with the highest probability, highest complexity diagram on the exam, the human heart. This cross-sectional diagram of the heart introduces the symmetry trick. Anatomical right and left are inverted from your perspective. Differentiate 4 critical structures: the upper atria, the lower ventricles, the aorta carrying oxygenated blood out, and the vena cava bringing deoxygenated blood back. Another frequent target is the nephron, the basic filtering unit of the kidney. You need to clearly draw the Bowman's capsule, the cup-like sac at the beginning of the tube, and the glomerulus, which is the cluster of capillaries inside it. You will also need to contrast specific blood vessels. This table details the structural differences between arteries and veins. Arteries have a thick outer coat for fast blood flow away from the heart, while veins have a thin coat for slow flow back toward it. For plant reproduction diagrams, the grading relies on one specific visual indicator. You must clearly show the pollen tube traveling all the way down the style to reach the ovary. Artistic shading will not earn you extra credit here. Biological diagrams are scored strictly on structural accuracy and correct anatomical orientation. Moving to physics, drawings shift from anatomy to logical relationships. We'll start with Ohm's law circuits. This simple electric circuit diagram requires a placement mnemonic. The ammeter is placed along the wire in series, while the voltmeter is vis-a-vis in parallel. You must also include directional arrows on the wire showing current flowing from the positive to the negative terminal. When drawing magnetic fields around a straight wire, you need to apply the right-hand thumb rule. This is a method to find the field direction by pointing your right thumb with the current, letting your curled fingers show the circular magnetic lines. To represent the strength of that magnetic field, you vary the physical spacing of those concentric circles. Lines drawn closer together near the center indicate a stronger force, and they space out progressively as the field weakens. For optics, ray diagrams are governed by strict geometry. The primary rule is that a light ray running parallel to the principal axis always passes through the focus, which is the convergence point for the light. This convex lens ray diagram places the object on the left, specifically beyond the 2F1 mark. Follow the paths of the refracted rays. The exact point where those lines intersect on the right dictates the image location, dropping perfectly between F2 and 2F2. If you omit a single directional arrow in a physics diagram, you invalidate the entire mathematical proof. The examiner will mark it as an automatic 0, regardless of how straight your lines are. Chemistry diagrams test your ability to visually represent exact physical proportions and invisible atomic relationships. Take the experimental setup for the electrolysis of water. This is the process of using electricity to split liquid water into hydrogen and oxygen gases, collected in inverted test tubes. There is a critical visual trap here. Because the chemical formula for water is H2O, the empty space for the hydrogen gas in your drawing must be exactly twice as large as the oxygen space. To demonstrate stable valence sharing, how atoms combine by sharing their outermost electrons, you construct electron dot structures. You have to show the distinct configurations for different molecules. Methane requires a perfect octet of 8 shared electrons, while ammonia must be drawn showing its distinct unshared lone pair at the top. This graphic compares exothermic reactions, which release heat into their surroundings, against endothermic reactions, which absorb heat. A valid chemistry diagram requires strict mathematical precision. Whether it's the specific volume of a gas or the exact count of valence electrons, the proportions must be perfect to earn the points. Let's review your exam checklist. The physical requirements are non-negotiable. Use a ruler, stick to a pencil, and align all labels neatly on the right. Before moving to the next page, do a final sweep of your drawing. Check every directional arrow and verify that your physical proportions match the chemical or mathematical reality. Executing a perfect rules-based diagram serves as undeniable visual proof of your scientific competence. It locks in up to 16 points before the examiner even reads a single written answer.